Hi, I'm Jakub Perliński and I am a member of February in Space Student Association. We have been functioning at the Wrocław University of Science and Technology since November 2017. This year's project is the R4 Lynx rocket, which consists of 8 departments. In the figure on the left you can see all of them, about which we would now like to tell you more. We'll start with the rocket's main section, that is the aerostructure subsystem.
Aerostructure department is the department responsible for modeling and integrating all the elements into a whole. The main task of this department is to build the airframe structure. The entire aerostructure is mainly made of carbon fiber and fiberglass. Each part is wound by team members either by hand or using a winder machine which was designed and built by one of our members. The choice of carbon fiber was driven by its strength and lightness. Bodies and interfaces are created by infiltrating wound glass or carbon mats with epoxy resin. This ensures durability and simplicity of manufacturing. The cone is made of carbon fiber fabric, which is placed in a mold. As with the other body parts, the finished head is trimmed and polished. The fins are designed with special attention to their weight and aerodynamics. Appropriately sized strands of carbon fiber are laid in a mold and then drenched with a mixture of epoxy resin and hardener. The mold was made using 3D printing technology, then sprayed with spray putty and heavily sanded. Properly cut fins are carefully weighted and polished to get the best quality.
To prepare the rocket and lift it to the given altitude, the team developed a hybrid engine. The engine's technical name is H110 due to its nominal total impulse, which is 11,000 Newton-seconds. The power comes from the combustion chamber, which is able to provide up to 5,000 pounds of thrust. The grain placed inside the chamber is made of polypropylene filled with enriched resin. Combustion is created by burning the preheated grain with oxidizer, in our case nitrous oxide. The oxidizer is transferred from the tank through the automated ball valve mechanism. As far as the oxidizer tank is concerned, during the design process, one of the main targets was safety. To achieve this goal, the control and bleed valves used in the design ensures that pressure inside the tank will not exceed predicted level. The control valve is automated and helps during the filling process, which is also done remotely.
Our new R4 Lynx rocket has completely redesigned electronical system, which will contain 4 modules. First module inside the rocket will be the main computer, which is responsible for both separation and managing all the things related to measurements and wireless communication inside the rocket. It is really hard to place wires through the whole rocket. We decided to make communication inside the rocket also wireless using XBee or ZigBee system. The second module is Prandtl tube module, which is responsible for taking pressure measurements from the Prandtl tube and sending them to the main computer. The third module is engine control module and is responsible for controlling main valve of engine of our hybrid engine. And also the next module is outside the rocket. It is fueling and ignition module, which is responsible for do all the things which we have to do before the launch. Last electronic part that we have but is not a part of the rocket is our ground station, which is connected to our computer and is receiving all the data transmitted by the main computer in the rocket and saving them on the computer in special application which is also developed by us.
The recovery system team is responsible for making the flight safe for us and the rocket. When the rocket hits apogee, the nose cone is pushed away. The drogue parachute shows off and fills up with the air, slowing the descent to about 82 feet per second or 25 meters per second. It's called the first stage of recovery. After about 110 seconds, the rocket is located less than 500 meters above the ground level. When it happens, the main computer sends a signal to our mechanism in the main second stage. The big parachute is deployed and slowing the descent to only 16.4 feet per second or 5 meters per second, making the landing safe and soft. Making two-stage recovery is more challenging, but it allows us to reduce the distance of the landing point due to decreased time in high altitude where the winds are stronger. As with every part of our rocket, our system is tested a lot of times before the launch to make sure it will work in flight.
The goal of the system is to reduce the rotational speed of the rocket around its axis. The system is modular with respect to the rest of the rocket and can be removed without the need of changing any of its components. Orientation of the rocket is controlled with 4 canard fins. Every fin is attached to its own servo mechanism. A STM32 F411 Discovery board was used to determine the orientation of the rocket. The data from accelerometer, magnetometer and gyroscope were gathered and processed by microcontroller. Custom-made PCB was used to supply power to the board and servo mechanisms, save the data on the SD card and connect relevant pins on the board.
The main objective of the payload chosen by the team will be to test the effect on survival in cancer cell growth of 2 animal species, the earthworms and the wandering polychaete. Earthworms are undeniably one of the most necessary ecosystem components. In the context of space exploration, research on earthworms is highly desirable in order to be able to send them into space stations in the future to develop mini ecosystems. An important factor that accompanies upward flight is the increase in cosmic radiation, which can have a significant impact on development of cancer cells. 2 groups are given, the first to be studied directly during the experiment, and the second control group that will stay on Earth and serve as a group to monitor changes. All samples will be carefully analyzed with the help of students from our university. After a successful flight, the specimens will be re-examined and monitored for 30 days to determine their survival and development.
The key idea of the simulation is to test your rocket without actually having to launch it. There are some simulators available, such as OpenRocket, RocketSim, or Kerbal Space Program. Now, imagine for a moment that there was a program that gets all the best out of every simulator available, combines it with CAD modeling, and adds the ability to watch your rocket fly using a dedicated graphics engine. Soon, there will be no need to imagine. The most recent addition to our team is the simulation department that is currently developing a modern rocket flight simulator. We are a small team that consists of 12 members that are further divided into physics researchers and programists. We have been working tirelessly for the past few months to make the dream come alive, and we have already developed one of the key parts, the engine. As the project is only 3 months young, it is not an overstatement that what we have already achieved is impressive for such a small team. The main idea is to make a great tool for small experimental builds, but when we achieve this, the sky is the limit. We have plenty of ideas, such as adding simulation of rocket computers, controlling the thrust vector, and adding steerable fins. We also want to listen to the community and provide you with the best, most user-friendly program. What makes our project special is that the whole thing is based on our construction team's experience and real-life flight data from our previous builds.
Finally, we will introduce, last but not least, the PR and marketing department. The work of our department consists mostly of finding ways to raise funds for the project. That is to encourage partners to help us achieve our main goal, which is to build the rocket R4 Lynx. That is today presented and described in detail. Our goal is not only to raise funds, but we also deal with promotion through which you can associate us. We are happy to be able to construct and build rockets and participate in many international competitions.
Thanks to our work, we want to develop a space field in Poland and move forward with innovative projects.